Inverse functions, the basics. So let f of x and g of x be two functions such that f of g of x, that's that composition, f composed with the function g of x equals x for every x in the domain of g. And g of f of x, so either way you compose them, they both equal x for every x in the domain of f for this one. So f of g equals x and g of f equals x. Okay, so we could have written that f of g equals x equals g of f. Okay, we could have written it that way. So that's the same thing. All right. The function g is the inverse of the function f, denoted f with this -1 exponent. That's, you read that f inverse. Okay, you read that f inverse. So thus, if we put f inverse right here, then we get this. Okay, so f of f inverse of x is x, and f inverse of f of x is also x. That's all it says. The domain of f is the range of f inverse. The domain of f is the range of f inverse. So it's like you're swapping the domain and range, swapping the x's and the y's. And you'll see that when we find them, how that works. All right, so the domain of f is the range of f inverse and vice versa, meaning the domain of f inverse is also the range of your function f. So let me just talk about the steps to find the inverse function. One, we're going to replace f of x with y. So, f of x and y are interchangeable. They're the same thing. So I'm just going to start by replacing f of x with y. Okay. Step 2, I'm going to swap every x and y. Swap my x's and y's. And I didn't write the word all in there, but if I have 27 x's, I'm going to change all 27 of them to y's. Okay. So swap every x to a y and every y to an x. All right. The third thing is solve for what I call the new y, okay? Solve for what I mean is, right, you just swapped them, right? So now something that wasn't a y is now a y. Now solve for that y, okay? And after you do that, replace that new y with f inverse of x, okay? F inverse of x. So those are the 4 steps. I'm going to color code them with this sort of pink or fuchsia color, this blue, the green, and then the gray in the end. All right, so I'm going to do the same 4 colors. So let me go ahead and pick that color now, okay? So I'm going to have those same 4 colors or very similar colors as I go through and do these steps. So actually first I wanted to determine if f and g are inverse functions. So how do we say we could do that? We could say f of g of x. Okay, in fact, let me do this. F of g of x, all right, must equal what? Must equal x. So let's go through this. The rule for f is 2 times something minus 9. Well, what is the something? The something is g of x, right? But wait a minute. What is g of x? G of x is x plus 9 over 2. So what we have is we have 2 times that g of x minus 9, right? And you could have changed g of x to this other thing first before you wrote the rule down for f. There's not a right or wrong way to do that. It's just a preference. Okay, and one or 2 steps is different, but you end up with the same thing. So what I'm going to do then is remind myself, hey, wait a minute. This is really over 1. Those divide out, and we're left with x plus 9 minus 9. Those cancel, and we're left with x. So that part checks out. What is the other thing that has to happen? The other thing is g of f of x has to equal something, right? G of f, what is f of x? Well, f of x, let's see. So what is the rule for g? Let's do this different. G, let's do this the other way, okay? So what is f of x? It's 2x minus 9. So see, over here, I went with g into my function of f, right? Over here, I went ahead and said, you know what? Let's replace f before we go into the function g, all right? So here, the rule for g is what? A fraction, something plus 9 over 2, right? What is that something? Well, it's f of x, which we know is what? 2x minus 9. So now we go and work this one, and look, these parentheses on this one are not necessary, but we're going to go ahead and say this is 2x minus 9 plus 9 over 2. Those things cancel, and we're left with 2x over 2, and those divide out. That's x, and check. It checks, okay? So f of g of x equaled x. F of g of x equaled x. And g of f of x equaled x. A lot of times in math we have these three dots. Therefore, ergo, henceforth, to, there, whatever, I don't know. All right. So therefore, f and g are inverses. Okay? F and g are inverses. Or f is the inverse of g, or g is the inverse of f, however you want to say it. Okay? But the key is, yes, they're inverse functions of each other. All right? And it's because f of g was x and g of f was x. So we got a little bit of practice of composition of functions here as well, right? But then if you're told to show two functions are inverses or to determine if they are, this is how you do that. If either one of them had not been x, it would not have been the inverse. All right, so here's my 4 steps. Hope I can remember the colors now. All right, so then we have f of x equals 5x plus 8. F of x equals 5x, and I'm going to remind myself, I think it's blue, green, and gray, but let's just go back and check real quick. Yep. All right, it is. Just making sure. So f of x is 5x plus 8. So for step one is going to be y equals 5x plus 8, right? I replaced this with y. That's all I did. Step 1 is always going to be literally one step. Not a play on words there, right? Step 2 is going to be swap my x's and y's. So here I had y becomes an x equals 5y plus 8. It is also always one step. You're literally just rewriting it and changing every x to a y and every y to an x. In this case, we only had one of each. The third step is where all the magic happens, okay? So the third step is where we're going to solve for this new y. So how do I get y by itself? Well, I need to undo addition and subtraction first. I'm going to subtract 8. That cancels. I get x minus 8 equals 5y. Then I need y by itself, so I divide by 5. That divides out. X minus 8 over 5 equals y. And there is step 3, okay? And then step 4 is also one step, okay? So for step 4, I'm going to say x minus 8 over 5 equals f inverse of x, okay? And that is perfectly fine. Or a more common way to see it is f inverse of x equals x minus 8 over 5, because we typically put the f inverse of x on the left side or in the front. Either one. Look, if a equals b, then b equals a. This is a very basic principle or axiom of mathematics, that if a equals b, then b equals a. The order you write equals doesn't matter if they're equal. Mathematically, it does not matter. If your professor, teacher, instructor has a preference, then you need to know what that is because you're taking their test. Okay? I could care less, all right, because equals is equals. However, I have done this before. I have an answer box like this, f inverse of x equals, and I have a box. Well, if it's written this way, sometimes it confuses students. Well, how can I put it on? No, you can put it on that side, okay? So if you have an answer box like that, then obviously, it's already written on the left or the right for you. Okay, so but either order that you write that. So what I'm going to do when I go from here, I'm just probably going to go straight to this one and just say it's equal. Doesn't matter if I put it on the left or the right. So even though I'm going to have equals y on the right most of the time, I'm still going to put f inverse of x equals first or on the left. All right, as we go through this. So those are my 4 steps. So let's go back to the pink or the fuchsia here and let's. F of x equals the cube root of x plus 2 minus 6. Now, I call this the basics. If you get into square roots, you got a restricted domain because it has to be 1-to-1 and that kind of stuff. This video isn't going to address that. All right. So this is literally the basics of this, just the 4 steps. And then if you get even roots and if you get other certain types of functions, you have to do various things to get the inverse to work for you. So here, or to find it, I should say. Step 1 is to do what? Change f of x to y. That's it. Just you're copying everything else down. Look, make sure that you don't do this. All right, you can do that, and some people put a porch. If you put the porch, that's fine. But if you put it like that, what if there was an x here? Is that x to the 3rd power, or is that the cube root? Right. So I always, if you notice the way I wrote it. In fact, I'm going to move this over just a little. I don't like it touching. If you notice the way I wrote it, I wrote my 3 first, and then built my radical around it. What I mean is, I didn't do this. I didn't do that. I usually put the 3 first in the index, and then or the root, and then I go through and. There was something on the screen. And then I go through and put the radical after I put the index. So step 1 is there. Step 2. See, we said it was a blue, right? Step 2 is just going to be swap the x's and y's. So x equals the cube root of y plus 2 over what? I'm not over, minus 6. And then step 3 again, that's where all the magic happens. Step 3, we're going to say we need to add 6 to both sides because there's a radical over this, but you want the radical by itself so that you can get y by itself. So that cancels. You get x plus 6 equals the cube root of y plus 2. And then how do I get rid of a cube root? I take both sides and do what? Cube it. Now, I'm not going to get you to cube that. If you cube the cube root, you get y plus 2. I don't want you to cube x plus 6. All right? I just want you to leave it x plus 6, but it's got to be in parentheses cubed. If you cube it, that's okay if you do it correctly. Okay? So, I'm going to subtract 2 from both sides. That cancels, and I get x plus 6 to the third power cubed. All minus 2 equals y. So that finishes step 3. And then again, I just didn't have room down here. I'm going to get somewhere. I can't even get all of step 3 down there, I imagine. So step 4 is going to be to say f inverse of x, right? Change y to f inverse of x equals x plus 6 to the third minus 2. And I know I put f inverse on the left, but we talked about that, right? If it's equal to y, then y equals is the same thing. And y and f inverse, what you do, you're replacing that here. Okay? So there is your inverse function of f. Here, find f, and I misspoke. The square root would work itself out for the inverse. You would have to understand that their domain is already restricted. If you started with an even power, that's when you have to restrict it as you go through and work on the inverse. Okay, because you get the plus or minus thing. Right? So f of x equals x cubed minus 11. So step 1 is y equals x cubed minus 11. And then we're going to go through here, and number 2, step 2 is going to be x equals y cubed minus 11. And then step 3 is where the magic happens, right? So we're going to add 11 to get y by itself, well, y cubed right now. And we get x plus 11 equals y cubed. But how do I get y? So I'm going to take the cube root of this side and the cube root of everything over there. So the cube root of x plus 11 equals good old y. And that's where if you had an even root, right, the fourth root of y to the fourth is plus or minus y. The square root of y squared is plus or minus y. All right? That's because of absolute values and that kind of thing, or square root property if you want to, on square roots anyway. But even roots, the definition is it's an absolute value, and then there's a plus or minus that's involved with that. Okay, so that's why odd roots work themselves out. So no restriction of the domain or anything here, nothing special going on. So here we come over here. That's why I called this one the basics and didn't put that in there. So this is going to be f inverse of x equals the cube root of x plus 11. So there's your inverse function. Let's look at another one. Wow. F of x equals 2x minus 3 over x plus 1. The first step is to replace f of x with y, right? So 2x minus 3 over x plus 1. And then the second step is to swap your what? X's and y. So that's x equals 2y minus 3 over y plus 1. Both those x's become y's. Okay? Both those x's become y's. Now you got to solve for the new y, which is going to prove to be a little bit more challenging this time because you don't just have one y, you got two of them, and you got to get them on the same side together, not divided, and all this other stuff. So anytime, right? See, this, I like ways that always work, and this is where, you know, when teachers do 14,000 different things with fractions, students get confused and wonder why. Every single time I have an equation with a fraction in it, I multiply by the LCD on both sides, every term. Every term. So what is my LCD here? So when I go to solve this, my LCD is just y plus 1, right? So I'm going to multiply x times y, that's not a y plus 1 equals 2y minus 3 over y plus 1 times what? Y plus 1. I'm going to remind myself, hey, self, don't forget that's over 1, so that those divide out. That's the whole reason I multiply by the LCD, to get rid of my fraction. So on the left-hand side, I'm going to distribute here, and I'm going to get x, y plus x equals 2y minus 3, because these become 1 and they don't contribute anything to it, okay? So I'm just going to write it up here because I still got several steps to do here. xy plus 3 equals, I didn't mean to turn your stomach there while you're working this one, okay? Because I know everybody loves long, hard math problems. Okay, so I'm trying to get y, or I'm trying to solve for y. So I need all the terms with y on one side. It doesn't matter which order you do this, which direction you put this. And I wrote that down wrong. For all you screaming at the screen, I heard you. Oops, wrong button. Okay, I wrote that down wrong. This should be xy plus x, and then equals 2y minus 3, right? So look, don't be very careful when you copy something. This is a good lesson here. Be careful when you copy something. You may do all the work right after you copy it, but if you copy it wrong, it doesn't do you any good to do all the work right, does it? So I was about to do all the work right after this, most likely, but it wouldn't have done any good because I copied it wrong. But I went back and caught it, found it, okay? So xy plus x equals 2y minus 3. And so here, I need the y's on the same side. So it doesn't matter which way you move things. However you want to move it, I'm going to move this 2y over here. And if I do that, that cancels, and I get xy minus 2y plus x equals negative 3. But I don't want this term over here because I can't, it doesn't have a y in it, right? So I get rid of that, move it over by subtracting, equals negative x minus 3 or negative 3 minus x, however order you want to put it in. Now I have only terms with y in it over here. So guess what I'm going to do? I have a GCF of y. And then x minus 2 equals negative x minus 3. Then I divide both sides, right? If I had 3y equals 7, how would I solve for y? I would divide both sides by the thing multiplied by y, right? Well, guess what? What do I have multiplied by y over here? X minus 2. So that divides out, and I divide this side also by x minus 2. Do these x's divide out? No, you have two terms and two terms. You can never cross out a single term in something bigger than a single term, a string of terms, a polynomial, a binomial, a trinomial, or whatever. Okay? So y equals negative x minus 3 over x minus 2. And so step 4 is f inverse of x equals negative x minus 3 over x minus 2. All right? So that is step 4 right there. So we're done with that one. But I want to tell you something. See all these negative signs and everything else? And I chose to move the 2y. What if I had chosen to move the negative 3, or if I had chosen to move the xy? If I had done that, then this thing would look like this. So here's an alternative answer that is correct. X plus 3 over 2 minus x. Or you could have negative x plus 2. That doesn't matter. Okay. So that answer there is the same answer, right? If I take a negative out of this numerator, x plus 3, right? Then I move it down here, that makes that a negative x and a positive 2. Well, a negative x and a positive 2. So that's where that comes from, okay? You can either factor the negative out and move it to the denominator, whatever, or you could have, instead of moving 2y, I could have said minus xy here. And if I'd have said minus xy on both sides, then I would have ended up with this one right here. Okay? So either answer is fine. I want you to know that both those answers exist depending on what you chose to move, but they are there. All right? So hope this helps with inverse functions.